Hey, so today I wanted to give you a demo of developing a feature for Magenta inside of Magenta. I think this is probably going to be a good way to both see how I use it in my day-to-day workflow, and also to understand the structure of the plugin in case you maybe wanted to contribute to it someday. So the goal for this session is going to be to set up local overrides uh, for the options for the plugin. Um, so I'm going to dictate the goal to the agent. I have this tool called Super Whisper, but I think any operating system is probably going to have some way to translate speech into text. So let's get started. I'd like to set it up so that each project can provide its own settings file for Magenta. I'd like it to live in the .magenta/options file. I would like this to be a JSON file. So when Magenta starts, it should check for the presence of this file on disk. And if it is present, override the settings there over the ones provided in the central plugin option. Okay, so now I have the prompt, and then I'm gonna just give it a little bit more. I'd like you to plan out this feature first before going into the implementation. And then I also want to tell it that there is an existing option setting. So I already have an option setting that is provided as part of the plugin config. So definitely look into how that works before going into the rest of the task. All right, so I'm kicking it off here. So a few things that you'll notice right away. One is that we have an option for automatic context detection. That's actually one of the options. So you can configure the plugin with a set of regular expressions, and the plugin will check for those files and automatically include them in any request. So here we can see the context updates that were sent along. The other thing is that these are updates, right? So since this is part of the context, we will now track the changes to this file and track the version of this file that Magenta sees, and will continuously update the file if any changes to the buffer or the file on disk are detected. So let's see what the agent is doing here. Okay, so first it says, let me examine the current option system and then create a plan for per project settings. And here you can see one of the new features that I recently added, which is subagent workflows. So exploring a code base can use up a lot of tokens, and the agent has to read a lot of files, not all of which are going to be relevant. So for that reason, tools like Claude Code developed this feature of subagents, and I added this to Magenta recently as well. So here we can see that we started a subagent with a new thread ID, and if I hit enter on this line, I can see the some more detail about like what the tool use that prompted this was. So we can see that we used the learn system prompt, this tool of spawning subagents. There's a learn system prompt and a plan system prompt that provide more detailed instructions to the subagent about how to go about doing this specific task. And then the parent agent, the agent of this thread, composed a prompt for it, which is need to understand how the current option system works, etc., etc. So that's cool. We know another thing to notice here is that this call is non-blocking. So we spawned the subagent with a thread ID, but then the agent continued operating, and then it used this other tool, which is wait for subagent, that allows it to spawn multiple subagents simultaneously and then wait for them to complete, so that we don't actually have to run subagents one at a time. So underneath here, we can see a summary of the threads. So here we have our subagent running, and right now the subagent is stopped on the tool use. So something is going on in here that I need to look into. So I'm gonna hit enter on this line, and that takes me to the other thread. So Magenta now supports multi-threading. Part of the reason I implemented that was for the sake of this subagent subthread system. If I hit dash within this display buffer, it will take me to the thread overview page. And here I can see all of my threads. So my thread 1 was the parent thread, and then it's kind of hard to tell, but indented here is thread 2. So these are organized in the tree view. And I can see that I have a child thread here that is stopped on tool use. The star shows which thread is currently active. So if I hit enter here and go back, I can see that thread 1 is now active. If I hit enter here and go back, I see thread 2 is now active. So let's look at what's happening in thread 2. So this got a prompt and a set of instructions. The prompt kind of just it's the learning prompt, so it just kind of tells the subagent to recursively look through interfaces, files, and things like that so that it can thoroughly understand how things work. And there's also instructions on how to return back to the parent agent when it's done. So here we can see it's reading some files, and then it actually wants to run a bash command, which it doesn't actually have permissions to do yet, which is why it paused. So this is a security feature. We don't want the agent to just be able to execute arbitrary commands without the developer say so. So this looks like it just wants to look for TS and Lua files that contain JSON or config or Magenta. So I'll let it run that command, and then it will proceed. So you can see it actually ran a second command, and in this case it didn't ask for user permission. So this is because part of the options file allows you to provide regular expressions for bash commands that can run without user permission, and just a regular grep command falls within that. So I have it configured to just run directly without needing intervention. So it's just gonna continue looking. I think it's just trying to find all of the possible things that might have to do with options, and it will churn for a little while. While it's working, the other thing that's worth noting here is that I now have a token estimate appearing in the header of this input window. So here you can see we're now at around 23,000 tokens. In my experience, staying under like 50 to 60,000 tokens on Sonnet, it tends to work pretty well. When we get past that and start getting up into the 100,000 tokens, it tends to kind of lose the thread a little bit. So it ends up forgetting things and so on and so forth. So let's see what happened here next. So it finished looking at those things, and then here you can see it yields back to the parent. Oh, we spawned another subthread. I was confused about what happened there. Right, so it yielded to the parent, and then here we can see the statement that it yielded. So it kind of really elaborated on how the options are currently set up and so on and so forth. So this is great information now for the parent agent to be able to continue its work. But you can see that here we've only used up, maybe 1,000 tokens or so, rather than the entire background of this thread, which was getting into like 30,000 token limit. So this is really the goal of the subagent flow, is to keep context windows focused and keep them from growing too large, which I think also helps with cost. So this is hopefully now going to be cheaper overall than if all of these tool invocations and exploration were part of the parent agent workflow. So let's check up on what's going on with the parent agent. We have our first command, which researched all of those things and he returned. And then we can see the response that it sent back, which we already looked over. And then it continued operating here. So let me create a comprehensive plan for implementing per project settings. So this is the other subagent prompt that I provided, which is the planning subagent prompt, which spawns a subthread, which has a pretty extensive system prompt. I can actually show it to you. So if you look at the system prompts file, you can see all of the various instructions that I send to the agent. And this is open source, so if you read through this or you play around with Magenta and you don't like how the agent is behaving in certain cases, please feel free to go and edit this and submit a PR. Unfortunately, for companies like Anthropic with Claude Code or Windsurf or Cursor, they don't show you these things. These are kind of the secret sauce, I guess, which to me feels kind of silly because these are just prompts. It's not anything complicated. It's just trial and error, and it's not a very precise science. So I'm hoping that with the open source community, we'll be able to iterate on these and come up with some really nice prompts to get the agents to behave in a really helpful way. So the planning prompt is here, plan subagent system prompt. And it just tells the agent what the goal is, gives some guidelines about what a good solution is. So make sure that we understand how similar features in the code base work and so on and so forth. Avoiding premature optimization. A lot of these are kind of wishful thinking. I don't know to what degree the agent is actually going to produce anything different based on this. I do find that without a prompt, Claude at least tends to give very, very generic implementation instructions. It's just do this thing, but it doesn't actually spell out how it plans on doing that, and that tends to lead the agent astray in more complex tasks. And then we say write the plan. And then always with prompts, it's really good to give the agent an example of exactly what you're looking for. So here we have an example plan that we want the agent to generate. And you can see the example I provided here is very, very specific. Each step is small, very well outlined change that I want the agent to make. And the goal here is that I think ultimately we want these to be completable by subagents. And I think that would be a pretty cool way to extend this in the future, is to split things up into tasks like this and then have a subagent iterate on each one of these top level items and implement them one at a time. All right, so let's get back to what is going on here. So we called this planning subagent and then we waited for it to complete, which it did. And then here's the response. So instead of just directly spitting out the plan here, I have the plans configured to be written to this plan subdirectory. And the goal of this is that I want the user to actually be able to look at the plan and review it before the agent starts implementing things. So this is exactly what we're looking at here. So now Magenta has paused so that I can actually review the plan and see what we're doing here. And the agent has been churning for a while and has done a lot of different things. But you can see that we're only at about 10,000 tokens here. So this output at the end of each turn kind of tells you how well you're using the cache and things like that. There's a little bit of a bug where when you switch threads and open and reopen the sidebar, we kind of lose the token count here in the thing. So, but even so, I think we can tell that there's about 12,000 tokens that are being used up right now. So that's a lot of work, and the context window for the main task is still pretty small, so I would say that's a success. So yeah, if we look at the threads, we can now see we have our parent thread and we have 2 yielded threads. All right, so let's see what it came up with respect to this plan. So it's gonna put the plans in the plan subdirectory, and we have the per project settings plan here. And so I asked it to provide a little bit of context near the top, so that if a subagent is just reading this plan, it's going to be able to see what the relevant files are and how things are organized. So this is probably just condensing some of what that learning agent, the information that the learning agent provided us. And we have the implementation plan here. Okay, so let's take a look. What is going on here? Project setting, detection, and loading utilities. So it's saying, so yeah, I like this. This is very specific. Like, add this function to this file. This seems very specific. Options.lu is probably a good place to find it. I think it's not really clear what these files should do and why we're splitting it up into 2 functions. So that's a little funky. I think I will probably just say load project settings function to locate them in individual files. Okay, so we're gonna add this file. It's gonna load those settings. I wanna add the thing here. Parse the file and make sure it fits the let's see, options.lu or options.ts. So there's a magenta options class here, so I just want to make sure that we read type, so that we parse the file and make sure that it fits this type signature. Then we are going to add some error handling. This is like pretty generic. Like, what does error handling mean? So I think we probably want to give a little bit more guidance. I think we can actually just tackle that later in the plan. Okay, so the options precedence systems modify set options to accept project settings as a third parameter. Options, set options. Oh, so that's not really clear about where it's talking about, so that's unfortunate. Let's look at the plugin. So here we have the parse options thing. Okay. So it looks like we parse the options when the plugin is being initialized, and I think I want the project options to happen at kind of the same time. So I'm gonna update this. So oh, I wonder if it's working on the thread here. Thread options. No? Maybe chat? No? Okay. So this is the thing. This is why it's important to review your plans. So I think what I would like to do is just skip this. This does seem kind of silly. So yeah, so plugin initialization flow. I think that's what we should do next. So we're gonna update the setup to detect and load project settings. No, that's not right. We shouldn't be doing this on the Lua side. Yeah, so this is not right. So yeah, so this is like, I guess this is why I wanted to record a demo of myself actually working on a real coding feature, is because I see so much stuff out there about like vibe coding and how smart agents are getting and et cetera, and I haven't been able to actually get an agent to complete a feature of this complexity, which, like, this is not a very complicated thing. I chose this for recording the video because it's a pretty straightforward thing. Like, it requires understanding the structure of the existing implementations and things like that. But But as you can see, even with seeing all of the code and how it works, like we really are struggling here to understand how to implement this best. And I think it got confused about the fact that there's some options that are defined on the Lua side and some options that are like the option parsing code is defined on the TypeScript side. So even though it put the detection stuff into the, oh, okay, I see what the problem is. It's really trying to implement this on the Lua side. Okay, so I would like not to do it this way. So what I'm gonna do now is just tell it to amend the plan. So I don't actually, I always forget to use the voice. I don't actually want to implement the file reading or anything on the Lua side. I would like to do this as part of the plugin initialization process on the TypeScript side. Can you update the plan to reflect that? Okay, so I'll make sure that that is written. And then you can see here I included this plan file in the context. So if I make any manual changes to this file, the agent is going to see the diff relative to what its view of the file is going forward. So let's kick this off, and hopefully it will be able to use the information in here to modify the plan and get us something closer to what we want. And you can see here also that this is the benefit of putting the plan in a file, is that it can then use the replace tool to kind of manipulate the plan piecemeal. I think the alternative would be if the subagent, the planning subagent, just yielded the entire plan into the context window here, then if we wanted to change the plan, we would have to kind of rewrite the whole plan within just within the context of this parent agent, which I would like not to do because that is kind of painful. So maintaining this artifact I think is really useful. And in case you lose the context for some reason, or you close the plugin and you can't get back to it, having this plan file is just a really nice way to operate. All right, let's see how it changed. So find project setting. Okay, so it's doing the same thing with splitting this up into two functions for some reason, which I don't care about. Okay, modify settings as a parameter. Yeah, so I don't really understand what is the parse options. Yeah, that's not really clear either. I think, either way we're gonna get a JSON file here, so I don't know what we need to modify about this. So let's just delete this part. I think the precedence rules are gonna happen when the plugin startup code is actually running, so we're modifying the initialization flow. And we want to, update the start function so that we load the project settings before parsing options. Okay. Yep, so we want to load the project settings before parse options. Okay, so rather than storing the project settings separately, I think what I want to do here is to just combine the project settings with the plugin settings before passing them into the magenta structure. So I want to just have still a single options object, but I want to have them combined between the Lua settings and that. So let's look at the magenta options type again. and see what we're dealing with here. So we have profiles. So I just want to, we're not going to do that. So project profiles should override, should replace plugin profiles. The active profile is fine. That's something that's derived. Sidebar position is fine. Okay, so command allow list should be combined. So we want the project file to be able to define additional command allow lists rather than replace it. And outer context should be combined as well. Okay. Yeah. I don't really feel like this is a necessity. It's a whole separate point, so I think we're gonna just delete that. We're gonna delete that because this is already handled by parse. We'll just add here when project settings are, actually maybe in this point above, when project settings are malformed, we should just ignore them. Okay, testing infrastructure. Test utilities for project settings. I think we're gonna tackle this later. So this is getting into a lot of, like, this is the tendency for LLM agents, I think, right now, is to just try to do way too much. Like, they really go above and beyond. Like, and it's kind of annoying because, you know, like, this is so extra. Like, I don't really need this. I can probably just prompt it a couple of additional times. After this implementation is done. So I'm gonna just skip testing within this plan, and then we can revisit it later, probably outside of the scope of this video. Okay, project settings file format. Okay, so it's giving it examples about like profiles, sidebar position. I think I'm gonna ignore the sidebar position thing here. Precedence logic. Yeah, this is like too verbose. I think we don't want the current working directory. We want, so I think we're just gonna look for magenta relative to nvim's CWD, and I have some helpers here, so we really wanted to nvim CWD. You can use the get CWD helper in node nvim.ts. I don't need to walk up the directory tree or cache or whatever. That's, again, extra. We're gonna ignore that, we're gonna ignore that, and we're gonna ignore that. Okay, so this plan seems solid, and I think we can proceed. So here I'm going to, so again, like, we did some extra work here in terms of like editing, iterating on the plan and stuff like that. I don't really care about that continuing to be in the context, so I'm gonna now use the compact feature. So what this is gonna do is it's gonna force the thread compaction tool to run first before we proceed with the plan. So I say, okay, compact. Okay, I made some changes to the plan, and I think it's ready to go. All right, so what's gonna happen here? A lot of other tools have this compaction feature, and I didn't really like how it worked in tools like AMP code or Claude code, because I think it just compacts the thread in a generic way to like summarize the conversation so far, and I think the agent is going to be a lot more effective at summarizing what's happened if it knows kind of what direction you want to take the conversation in next. So that's why I kind of implemented this user experience here, where you start with a compact keyword and then provide the next prompt that you're actually going to use. So when we hit enter here, you can see that we're now doing the compaction flow, where the agent says, like, use the compact thread tool to analyze, etc., etc. Sorry, we're gonna pop back. It's kicked off the new thread, so we're gonna pop back just so we can see. Oh, and that disappeared. Okay, never mind. The agent gets a message that says, like, hey, use the compact thread tool to summarize this conversation for the purposes of continuing this conversation, and the user's next prompt is going to be blank. It then is required to use the compaction tool, and the compaction tool, when it's invoked, creates a new thread. So we can see here that we have the first, like, top level thread with the two subthreads, and now we have created a new thread, which is this thread 4, which is the compacted version. So this kicks off with the context updates and a previous thread summary, and, like, here's what we should go on to do next. And this was generated by that previous thread. So this acts like a compaction and a fork. So if we wanted to go back to here and spawn off a thread that went into another direction, we could use the compact tool here again, because this leaves the previous thread in a state where we can still interact with it. And if we didn't get some context, or we want to do, like, multiple things using the starting point, we can. All right. So when the thread is compacted, it allows the agent to specify which files should be included in the new thread. So we got the context file and the per project settings file here. And we got the summary of the previous thread and the message to, okay. So it's going to load project settings. It's loaded the options.ts file. It's making changes to that file, and it is now wanting to run some type checks. Yeah, I don't know why it keeps getting stuck on, like, /mnt. I don't know where it's getting this. So in the context file for this project, I have very clear instructions for how to run tests, which is just like npx test run. Really don't know why it keeps losing the thread here. So I'm just gonna ignore this request and respond. Just use npx test run. Or, oh, whoops. Okay, so this is another thing. It's not vytest, right? We want type checks. TSC. There should be. Oh, maybe that's why. Well, okay, that explains everything. Type checks. Use npx tsc no emit to run type checking from the project root. Okay, well, here I was wondering why the agent didn't understand what I wanted it to do, and it's because I didn't add that to the context. All right, so I just edited this file, and because the file's part of the context, I can just whoops, those were instructions for running tests. I updated the context with instructions for running type checks. And you can see here that since the file was part of the context, I only got the 3-line diff that I appended to this thing. And this works asynchronously too, so this, I think, is a really nice workflow where you can just, like, edit files while the agent is working on them, and it will, every time it uses a tool or something and there's a turn-taking interaction with the user, it will get updates about whatever files you changed. So here again, it's like cd into mint or mint mount. Don't cd into mnt. If you send a message, it will just ignore the previous tool uses. Okay, yes. And so here, this is really the reason why I want to use the per project settings, because I don't want to every time tell the agent that it like can run these things. So I'm gonna say always here. Always is always within this thread. It's not like always forever in the future. Once we have project settings, we'll be able to add this to the project settings file, and then we'll be able to run it without user approval whenever we want. Okay, so then it wants to run tests. Let's skip tests for now and finish the implementation. So I was kind of thinking about compacting here, but we're still at 15,000 tokens, so I think we're fine to keep going. Okay, so then it's gonna go on to looking at merging the project settings, and I implemented that in the options file, and so on. Okay. So I checked for errors again, didn't find any. I should move on to, really stuck on the test thing. I don't want to write tests yet. Just go on with finishing the implementation. Claude can be so stubborn about this stuff. I really don't understand. So there I'm using the abort feature, which is just leader MA. You can interrupt whatever the agent's doing, and then provide new instructions. Okay, so it's revising the plan. Okay. Okay. Oh, I think it's done. Let's see. Is it actually done? Huh. Interesting. So yeah, let's use Fugitive to see what's going on here. Okay, so I did make modifications to the magenta file, and we can see that it's grabbing the opts from Lua, and then it's getting the working directory from nvim. It's loading the project settings and merging them, and then passing them in. Okay, so this is interesting. It's merging them as unknowns, which is like kind of weird. I think what I would like to do, let's see, can it use the parse options thing here? Okay, so I think maybe the problem is that the parse options is requiring, yeah, so it's gonna throw errors if we don't provide like a full options thing, so that's interesting. How much do I like it merging them while they're unknown before parsing them? I almost want to create like a parse partial objects or parse partial options maybe, or yeah, let's do that. I mean, this is the sort of stuff that that LLMs are really good at, so I'm gonna split this off into a new thread. So I'd like to not merge these as unknown objects. Instead, make a new helper to parse the project options file and generate a partial magenta options object. This should be more forgiving than the parse options file and ignore errors. And just omit malformed fields with warnings instead of throwing Errors, definitely pull out reusable parts of parse options into helpers so we don't duplicate code. All right, so I'm gonna kick this off. This is gonna fork the thread with a summary, and hopefully we'll get something nicer. So while this is working, I guess I'll start moving on to wrapping up this video. I guess the big question is, did the agent actually save us any time here? And I really have a hard time with this. Like, if I went with like minimal LLM use, like just autocomplete, or maybe not even that, like just using it in line to refactor, rewrite, like getting rid of toil, I guess, like getting rid of those things that are just manual operations that are really predictable. And I handled writing all the code. I think I would I have the structure of the project in my head. I would immediately go into the options file. I would write it from the start to use this like partial project or partial option parsing, and probably use the LLM to generate that and things like that. Like, would it have been faster than going through this planning process and revising and waiting for the agent to like churn through all of these things? Like, I genuinely think it would have been faster personally, like for me to just do this myself. So I guess this is like, I wanted to force myself to use this planning flow, and I do think that having a plan and leveraging the agents in this way can be useful sometimes, especially if you have something where you're trying to do large code changes that are kind of repetitive or predictable. I think creating a plan and doing all this stuff can actually be quite useful. But is this changing software engineering fundamentally in a way that you'll never, like, I don't know. It's hard for me to say. Like, I am part of some communities where people are raving about all these tools like Devin and OpenAI Codex and things like that, and saying that like, wow, like they're never touching code and it's implementing all these applications from scratch, and I always have to wonder, like, what is the kind of code that they're actually working on that allows agents to be so successful in those settings. And this is probably my cynicism, but I really feel like it's probably just very simple, shallow code, right? Like, if you're writing something that is like bespoke shopping cart code or whatever, like, you don't need to understand data structures. You don't need to understand, like, even stuff like this, which is like, okay, we have a plugin architecture, we have some things happening on the Lua side, we have some things happening at the Node side. It can really cause the agent to get tripped up and to not understand like the nuance of like, hey, the Node process is going to be running in a different working directory than the NeoVim process, and so that is a distinction that you have to be aware of. And if you're just vibe coding this stuff, the agent is going to make mistakes about this thing, and even very, very simple, small things that would never trip up a software engineer. Well, this would trip up a software engineer, so let's be fair. Like, if you're not a technical person and you can't get to the point where you can understand these things, like, you're gonna get stuck so fast. And I really struggle to understand like what these people are building that are building all of this stuff via LLMs with like vibe coding, strict vibe coding. So I really, if you are watching this and you're like, yeah, like I have a workflow that can produce like much better results than this, like, please record it. Like, record it yourself actually building something real in a code base, so we can see, because I think like this is my own plugin. It's pretty bare bones, but like the places where it falls apart, I feel like it's really the LLM that's falling apart. Like the context is there, the task is small and simple, like all the information is kind of available, but the agent is still not doing the right thing. Okay, that digression aside, looks like we made some changes, and okay, and again, like it's just applied it to the options file. All right, so let's add this to the context and like rewrite the option loading code in Magenta TS to use the new helper. I want to parse the option, the project options separately, and then merge the partial and full Magenta options. And again, even with this, like, I'm really fast with NeoVim. Would it have been faster for me to just go in and like make these changes? Like, probably the difference wouldn't be that big in terms of like writing it out in English versus actually just making the changes directly. And here you always run the risk of the agent having to, doing something wrong. Like you really have to be watching it very, very precisely. So I think having these options within Magenta is going to be really useful. I'm really glad that we have this tooling for NeoVim now. So fewer people will be tempted by Windsurf, Claude Code, and Co. But I do think that the future is just continuing to make the agent as useful of a tool to the programmer as possible for reducing toil. But all of the stuff here is probably best left to the engineer, or at least like under the immediate supervision of the engineer. But for reducing toil, absolutely, LLMs are super, super useful. All right, so let's see what's happening here. So we're parsing the base options, we're loading the project settings. Looks like this is already returning the partial Magenta options object, so I'm guessing that we're parsing the project options here. Okay, and then if we go in here, I'm gonna look at, it's just providing warnings. What are we? Logger. Okay, so we're passing the logger in, and the logger here is also provided. Yeah, again, oh, I guess these are functions. Yeah, so that makes sense. Okay. Okay, and we're doing the things, parsing the profiles, parsing the active profile, etc. And then when we combine them, I'm gonna assume that this is working correctly. All right, so moment of truth. I'm gonna make a new thread. So create a magenta options.json. Is that right? Settings path. Options.json. Yeah. Okay. So created a magenta options.json file in this project that contains setting to allow the agent to run type check and by-test commands without user approval. And we're gonna need the agent to understand what the format of those should be. So let's look at let's just give it the plan here. So I provided the plan for that feature, which has already been implemented. So yeah, again, I'm really, for the purposes of this video, trying to leverage the LLM as much as I can, but okay. So now it's the moment of truth. Let's see if this worked. So I'm gonna go to my dot files. I'm gonna switch over to using the dev version of Magenta, and then I'm going to install it, or I guess it doesn't need to be installed because it's local. Okay, so let's spin it up and let's see what we've got here. So if I load the context and check for type errors in the project, it now should be able to run this bash command without. Yeah, there you go. TSC no emit runs without user approval, so it looks like it's working. So yeah, so my next step here would be to write tests. I'm not going to bore you with that, but thanks for playing along. I'm going to maybe record more of these as they develop the plugin, because I think it will be useful for people who are wanting to work on this, or even to just pick this up to understand what someone who has been trying to use LLMs for a long time, like what workflows we have, because there's so much hype out there about this stuff, and it's like it's absolutely useful. I mean, there's a reason why I'm spending all this time building this plugin, but you know, it's definitely also overhyped, at least so far. You never know what's going to happen next. But I guess I'll close out with thanks to everyone who's contributed so far. I did create a ton of issues as I went, like as this feature set gets larger, and I'm implementing more and more stuff, I noticed a lot of stuff that would be nice to have, and I tagged a bunch of issues with good first issues. So these are like leaf note sort of things, you know, things that would be easy to jump in and like implement within a day or two. Especially if you're familiar with TypeScript, especially if you're familiar with front-end engineering, this is really structured like a front-end project. You know, there's like a React-like system for rendering the display buffer. Everything else is very standard TypeScript. There's a message passing architecture. If you're at home with like Redux or Flux, you'll be able to figure this out in no time. So I would really love some more contributions, either in improving the UI, building some of these features, setting up additional providers. I really would like to get Gemini set up for this. I'll probably work on that sometime soon. But yeah, I'd love contributions. And yeah, spread the word. We're up to like 200 stars so far. 232 stars. Yeah, as of today. But yeah, I want people to know that there's good LLM options for NeoVim. I mean, I use this every day for work. I never think about Claude Code or Cursor or Windsurf with Envy anymore. I think this is working great, and you know, maybe there's a marginal difference in terms of prompt quality or some particular feature set, but I think it's negligible at this point. Like the benefits I get from being in the NVim every day, which is an environment I love, definitely outweigh not having those fancy bells and whistles from other ones. Next on my roadmap is MCP support. I think this is probably one of the main blockers for people from using this, especially if they have MCP servers that are really key to the workflows. So stay tuned for that. All right, that's really it. Thanks, everyone.